Okay, now to question C. You are told that Richard's acceleration at equals negative 10, negative 5v is always positive for t is equal or greater than 10. And the question is asking, hence show that t equals 10 plus 1 over 5 ln 98 over negative 2 negative v, which I will write down for you. So the question is asking us to show this relation. How can we do this? We know we previously got the equation for dt over dv, correct? Which was 1 over a, which in turn was negative 10 negative 5v. Now, we want t to be in the front, and to get this is fairly simple. Since this is the rate of change of time relative to velocity, what we can do is integrate this function in terms of velocity to get t. So, in perspective, that is just 1 over negative 10 negative 5v in terms of v. This will give us t. That is the relationship between integration and differentiation. So if we do this integration, we can first bring out 1 over 5, well, negative 1 over 5 to the outside to make our process a bit simpler. And we get this. We know that here is a relationship of f dash x over fx, and that can be simply calculated as ln fx. Well, ln absolute value fx is, and that is shown in our data booklet. So if we do that, we get negative 1 over 5 ln absolute value 2 plus v absolute value. Note, this is indefinite integral. You might make a mistake here, but don't forget the plus c. Now we have the equation for t, but we have to show it in this case, which means we just have to get our c. Now the question is, where do we get our c? Well, previously in question A2, we were given that when time equals 10, the velocity is negative 100. V10 equals negative 100. We were given that, well, we found that as our answer. And we can add that to our equation over here. Since this is the equation of t equals, so henceforth, we can add in 10 as our t value and negative 100 as our v value and get our c, which we will do right now after I erase the board a bit. Okay, so as I said, put in the 10 and negative 100. So 10 equals negative 1 over 5 ln 2 negative 100 plus c. This is what we get. Now to simplify it a bit, 10 equals negative 1 over 5 ln negative 98 absolute value plus c. Open the absolute value. 10 equals negative 1 over 5 ln just 98 bracket plus c. This is the final simplified equation you get. Now to get c, we just move some variables around. So c equals 10 plus 1 over 5 ln 98, and that is the c we wanted to get. Now all we have to do is bring this back to our original equation that had the c. So what we do is t equals negative 1 over 5 ln 2 2 plus b plus, this was our original equation with the c, but now we got the c, we just add the c value in, plus 10 plus 1 over 5 ln 98. Now we simplify it a bit and we get 10 plus 1 over 5 big bracket ln 98 minus ln absolute value 2 plus v. Close big bracket. Now, knowing the operation between logarithms, a negative sign can just move this value to the bottom as a denominator. So what we can get is t equals 10 plus 1 over 5 ln 98 over absolute value 2 plus v. Well, this is not exactly the same, but since the question said is always positive for t is greater than 10, well, other ways, but we know that 2 plus v can either be 2 plus v or negative 2 negative v. But since the question asks us to show that it can become negative 2 negative v, we will say that the absolute value 2 plus v becomes negative 2 negative v, which is essentially the same. And we did show the relation, which is the answer for C. Okay, now to question D. It says, hence find an expression for the velocity v for t is greater than 10. This is a simple moving around the variable question. After we get our previous answer, let me just rewrite the equation. So we have our v, so just move around the variables. T minus 10 bracket times 5 equals ln 98 over negative 2 negative v. And since we can change this into e, e 5 t minus 10 equals 98 negative 2 negative v. We can switcheroo and get negative 2 negative v equals 98 times e negative 5 t minus 10. And just move it around, multiply